Hey, welcome back to RamZland. Today I want to show you how to use a spray bottle to make misting metal ions. Check this out. So in order to make my metal ion misters, I'm using glass mist bottles and calcium chloride. This bottle has potassium chloride, strontium chloride. Of course, I'm using distilled methanol. Lithium chloride. Over here I have copper chloride and iron chloride. I like to begin this project by printing out labels for each spray bottle, cutting them out and just taping them so I know which is which. To begin, I add a little bit of metal salt to each spray bottle. This is the iron chloride. And then I mix it with distilled methanol. Now most of these are highly soluble in methanol, except the strontium chloride. For that, I would dissolve strontium chloride first in water and then add a 2-to-3 ratio with methanol. And usually you'll have a high enough concentration of strontium chloride that was dissolved in the water to show up in the flame test. Next, I'll use a funnel to add my distilled methanol. Then I'll simply screw on the cap and give it a good shake to make sure that all of that iron chloride is dissolved in my methanol solution. And now you're ready to trade the cap for the spray bottle cap. And then you're ready to test your metal salts with a blowtorch. This is really the most exciting way to do the flame test. Okay, the first metal ion mister I'm going to use is copper chloride, and this will elicit photons with a wavelength of around 535 nanometers. Check this out. Oh, look at that. Isn't that awesome? Okay, here goes lithium chloride. Look at that. This has a wavelength of around 700 nanometers for the color red. Now let's test calcium chloride. This should emit photons that have a wavelength of around 609 nanometers, which is the color orange. Check this out. Oh, look at that. And now let's test iron chloride. This one looks kind of white with a little tint of green to it. Check this out. Look at that. Isn't that amazing? So what's causing those different colors? Well, when those metal ions are exposed to the blowtorch, the flame excites the electrons and they move to an outer energy level. When they return to their grounded state, each electron emits one photon, one particle of light, whose wavelength determines whether or not we can see it through the light spectrum. We can only see photons whose wavelengths are between 300 and 700 nanometers. So when you looked at lithium and you saw the color red, that was a wavelength of around 700 nanometers. Remember, a nanometer is just a billionth of a meter. Now, when you saw colors that were lower in wavelength, those have more energy. And that's what creates the different colors that you see in this awesome metal misting experiment. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.